Alright, this is going to be solving systems with two variables elimination method. Just elimination method, separate video for substitution method. This video is just elimination method. The goal with elimination method, we've got two equations right here. I've already got them stacked in a system. Notice the x's are lined up, the y's are lined up, and the constants are lined up. If the equations are not given to you with the like terms already lining up, I would recommend rearranging it so that they are. Technically you don't have to do that, but it will definitely help a lot with your ability to visualize this stuff. The goal here is I want to cancel out either the x's or the y's. The way we're going to do that is we're going to add these two equations together. We're going to combine them. Now obviously if I added them the way they're sitting right now, I'm not going to cancel out either of the x's or the y's, right? I mean, to show it, if I added them right now, 2x plus x, or 2x plus 6x would be 8x. Negative 2y minus y would be negative 3y. And negative 14 plus negative 2 would give me a negative 16. That's not helpful to me. That's just another equation. So I don't want any of that. What I need to do before I add them together is I'm going to need to multiply one of these equations, or possibly both, by some constant. Remember, constant is just a number without a variable. I mean, I'm not going to be multiplying by another x or another y. It's just going to be some number, a 2 or a 3 or a negative 4. It could be any number. It could be any integer. But it's just going to be a constant. The goal is to either get rid of the x's or the y's. It does not matter which one you choose to go for. But you need to make sure that the numbers are opposite signs, meaning 6 and 6 do not cancel out. 6 and negative 6 cancel out. So if I wanted to cancel out the x's, for example, I could take the first equation and I could multiply it by a negative 3. Because, and I'll write this down below here, negative 3 times 2x, negative 3 times 2x would be a negative 6x. Negative 3 times negative 2y would be a positive 6y. Negative 3 times negative 14, that would be a positive 42. Check out the x's there. Since we have a 6x and a negative 6x, this allows us to be able to cancel them out. Meaning, from this point on, we can ignore that first equation, at least until we want to plug back in. Okay, ignore that first equation. I'm just looking at this equation and this equation. I want to add those two together. 6x plus negative 6x cancels out. Negative y plus 6y is 5y. And negative 2 plus 42 would be a positive 40. Since I canceled out the x's, there's not much more left to solve this equation out. All I need to do is divide by 5. 40 divided by 5 is 8, so there's half of my answer. All we have to do now is go back to one of the original equations and plug in 8 for y, solve it the rest of the way out. Let's use the very first equation that we started with. We had a 2x minus 2y equals negative 14. Well, let's take this 8 and let's plug it in for y. 2x minus 2 times 8 equals negative 14. Negative 2 times 8 is negative 16. I'm trying to get the x by itself, so it'd be a good idea to add 16 to the other side, giving me 2x equals positive 2. Then I just need to divide by 2, and I get that x equals 1. Meaning, I have a final answer of 1, 8 as a coordinate pair, meaning x equals 1 and y equals 8. That's elimination method. That's not the only way it has to be done though. Let's restart this problem. 2x minus 2y equals negative 14. And we had 6x minus y equals negative 2. Let's try and cancel out the y's this time. Meaning the x's are fine. I want to multiply one of the equations by something that would cause my y's to cancel out. Well, in my first equation, I've got a negative 2y. In my second equation, I've got just a negative y. So I do notice they're both negatives, which means I can guarantee I'm going to have to multiply by a negative number. Because if they're both the same sign, they'll never cancel out. One of them's going to have to be a different sign, which means I have to multiply by a negative to flip the sign. Other than that, though, it's up to me, or it's up to us, how we want to do this. The easiest way, I think, would be to take the second equation and just multiply that by a negative 2. Because I already have a 2 right here. I already have a 2 in the first equation, so if I multiply the second equation by a 2, the 2's will just cancel out. So to do that, I'm going to rewrite down here, negative 2 times 6x is a negative 12x. Negative 2 times negative y, the double negative makes it a positive 2y. And then negative 2 times negative 2 gives me a positive 4. Just going to rewrite my first equation down here. 2x minus 2y equals negative 14. So let's add those two together. Negative 12x plus 2x is a negative 10x. The y's are canceling each other out. 2 minus 2 is 0. And then 4 minus 14 would give me a negative 10. Well, if I've got a negative 10x, and that's equal to negative 10, then I just need to divide both sides by negative 10, and I get that x equals positive 1. The exact same value we got for x on the last problem. Take that back to one of your original problems. Again, let's go ahead and use the 2x minus 2y equals negative 14. It could be either of your two original problems, it's up to you. But let's plug in this 1 for our x up here. So we'd have 2 times 1 minus 2y equals negative 14. That'd be 2 minus 2y equals negative 14. Subtract 2 over here. Remember, since it's negative 14 minus 2, that would be a negative 16, which means when we take negative 16 divided by negative 2, the double negative gives us a positive 8 for our y value. Notice that we got the exact same answer no matter whether we tried to cancel out the x's or the y's.